Okay, Marty. So this is now number, I don't know what number this is in video. Fifth one, I think, that I'll be sending you. Finally, want to get back to that. I know the topic that you want to know, which is how do we answer this question, which is a plan on how we'll analyze our data. So it still might take 2 videos to go to finish this topic. So first thing I want to do is I want to cover what I think our measurements will be and how we'll collect the data. And you know, you've heard an overview already, but I want to go in a little bit more detail. So again, we will be taking simple random samples of games that have been played already. Most likely for the years 2007 through 2009. That'll be 3 years worth of data we can pull from. Might include 2010 already, but that year is is like only halfway along. So it may be better for us to just say let's just choose sample games from 07 through 09. Well, that's a detail. What we're going to pick, or how we're going to pick it, is we're going to use again that kind of lotto ball thing that we use, that applet, or something equivalent to that applet, to basically pick 3 random values. And the first is which season, 2007, 2008, or 2009, or maybe 2010. Which team we want to pick, and again it'll be the visiting team. And then which series, which series that we want to pick where they were on the road. So now that part is kind of confusing. So I think you can understand the first two, which is like we'll pick a random number between 2007 and 2009, and then we'll pick a team, and then we need to pick which game where are we picking where they were traveling to a different city. Okay. Now on that one, if you look at a schedule, Major League Baseball schedule, they're split in terms of home games and away games. And typically what happens is a team will play at home for, let's say, about 6 games or so, and then they'll travel to usually 2 or 3 different cities, and they'll play like 3 games in one city, and then they'll travel to another city and play 3 games there, and then they'll either go to a third city and play 3 games there, or they'll come home, and they kind of iterate through that process. So by looking at any schedule, you could basically say if we wanted to pick the 5th series where they're in a new city, we could quickly find that. Like let's say it was Cincinnati Reds in 2008, the 5th road series. Well, we could look at the Cincinnati Reds schedule for 2008, find their 5th time that they traveled to a new city, and then that would take us to a game that we want. Okay, so that's how we'll actually find a random game where a pitcher's pitching for the first time in a new city. Okay, so that'll be how we select the games for the first time pitchers, and then the way we'll select a game. Yeah, okay, sorry. So that's how we're going to get our samples for these pitchers that we want to study. Now, we want to compare those pitchers with a different population. So what we're going to be doing is we're going to be doing what's called a 2-sample t-test. And that's one of the tests that's listed in your list. We're going to do a 2-sample t-test, and maybe even a 2-sample t-confidence interval. I'd have to look at for sure, but we're definitely going to be doing a 2-sample t-test to compare the pitcher who pitched with less than 24 hours of in the new city, with a pitcher that had more than 24 hours in the new city. So that means we also need to get a simple random sample of these other pitchers. So that will be exactly the same kind of approach. We'll pick randomly a year between 2007 and 2009. We'll pick a team, and then we'll pick a road series, the same way we did the other, and then we'll pick which game in the road series, starting with game 2, 3, or 4, that kind of thing. 4 if it was a 4-game series. So there's an additional number there because we need to know which game are we picking, the 2nd, 3rd, or potentially 4th game in a road series. Anyway, so that's how we'll get the samples for both populations. The first population being the opening day pitcher, and the second population being the other than opening day pitcher on the road. Okay. Now, for each of these games that we pick randomly, we will get a data point, an observation, if you will, for that game. Now, this is where what we actually will capture and put in our spreadsheet is we'll end up capturing multiple pieces of data. So first, for example, we'll capture whether or not, or we'll capture the ERA as calculated for the pitcher that game. We'll also calculate the WHIP, W-H-I-P thing. Okay. We'll also determine whether or not the pitcher qualified for a quality start. Again, that's a pass, yes or no, pass fail kind of thing. Okay. And then we're also going to keep track of a couple other things. We're going to keep track of some of the raw data, like WHIP. Again, it was a calculation involving the number of walks and number of hits divided by innings pitched. So we'll keep track of the raw data, like number of walks, number of hits, and number of innings pitched. ERA, if you remember, it had the number of earned runs divided by innings pitched. So we'll keep track of the number of earned runs that were given up. Probably also keep track of the number of runs, forget earned, or just the total number of runs, earned plus unearned runs. Then we'll also record whether or not the team actually won the game, and that's for a different reason, but I'll cover that one later. Okay. And then if we want, we can even calculate whether or capture whether the pitcher was credited with the win. Remember the first thing I covered, the win-loss record, whether the pitcher was credited with the win or blamed for the loss. Even though, again, I doubt we're going to really use that data. Okay. So again, we'll do this for the opening day pitcher. We'll also do this for the other for the non-opening day pitchers. Those are the two different populations. We'll probably get roughly about 50 samples of each. Again, we'll have an N equals 50 for both populations. Again, we can control that because given that the number of games played is up in the hundreds or thousands even over the last 3 years, we can get a random sample of 50 without any problem. Or for that matter, we could even go higher, but I think 50 seems like a decent number. I was tempted to actually pick a number where the square root of the number was a number that we just knew by heart, like have an N equals 64. So if you remember, we always have square root of N in a lot of our calculations. So square root of 64 would be 8, but I won't bother with that. We'll stick with something like 50. Okay, so that's the SRS. I'm going to end this video and we'll start a new one to cover the next idea.